Welcome to another episode of the Virtual Reality Reconstructionist, the premier podcast exploring cutting-edge technology for forensic investigation in virtual reality. I'm your host, Roger Ryan Ryder, owner of Triple R Investigations. Today, we're thrilled to have Eugene Liscio with us, a pioneer in the field of 3D forensic documentation, as well as the founder of AI to 3D Forensics and Recon 3D with us. Eugene is well known as an expert in forensic visualization, crime reconstruction. He utilizes advanced 3D technologies to create accurate and detailed reconstructions used in courtrooms and investigations worldwide. His company, AI to 3D Forensics, is at the forefront of integrating 3D laser scanning and photogrammetry to offer a comprehensive solution for forensic investigations. In his bio, he's a registered professional engineer in the province of Ontario, Canada, and is the owner of AI to 3D Forensics. He specializes in 3D forensic documentation, analyzation, and visualizations. He's also the developer of 3D, a new iPhone 3D scanning application designed for forensics. Eugene has testified in courts in both U.S. and Canada and in Europe, utilizing 3D technologies such as photogrammetry and laser scanning, and has also provided 3D scanning reconstructions to aid the juries. He is a past president of International Association of Forensics and Security Metrology and is an adjunct professor at the University of Toronto, where he teaches 3D forensic reconstruction and mapping courses. As part of the forensic science, Eugene is actively engaged in research, publishing, and mentoring students focused on 3D documentation and analyzing techniques. So Eugene, welcome aboard. Let's start by hearing about your background and how you became involved in 3D forensic documentation.
Hey, Ryan. Thank you very much for the invite. I appreciate it. And I was just thinking where we first met. And I don't remember where we first met, but I know where we last met. And I think that was at Rex, right? We were in person?
Yeah, it was. I think it was one of the AIFSM conferences. I just can't remember which state we were in, but it was one of those conferences we first met.
Yeah, to answer your question. So my background, I went to engineering. When I was younger, I thought I was going to be doing music, but that didn't work out. I have kind of a musical family, but I really liked science from a young age. I liked computers and things that fly. So when it came time to decide as a teenager what you're going to do, I finally decided I would go to engineering, and I started in electrical engineering, believe it or not. And I did that for a couple of years, but it wasn't for me. After the second year, I was just like, nah, there's no way I can see myself doing this. The university that I was at the time, it was called Ryerson Polytechnic University. It's one of the universities downtown in Toronto. It's had a name change now, but they had a really good aerospace program. And so I think I can do this. I jumped in and I never looked back. I stuck with it. It was painful. It was a lot of work. When some of the friends I had who were taking lighter courses like business and marketing, they'd be at the coffee shop complaining about how they only got an A-, and we were struggling just to pass. So anyway, fast forward from there, engineering, I got out and I got a job. I was working for what used to be McDonnell Douglas, and then it became Boeing. My time there was excellent. I had an amazing boss. He was so knowledgeable. He was really good at promoting me and getting me to build confidence. And there were a lot of senior, very intelligent people with a lot of knowledge. I worked in the materials and process engineering lab, which meant that whenever something failed or went wrong with the aircraft, anything that touched the aircraft, it could be something as the coolant that they were using on machining. It could be a heat treatment process. It could be the actual material itself. It could be paint. It could be so many different things. We would be part of the investigation and trying to figure out what went wrong. So it was a great experience in learning about all these different materials and things. We just had a really good group in the lab with tons of experience. So as a new person coming out of school, was amazing. It was just a great exposure. I went on after that to work at a company in the US, an aerospace company. They made machinery for aircraft. They built machinery that would wrap around the fuselage and the wings, and they would rivet. They would fasten the skins to the structure, let's say. And while I was there, I had a lot of exposure to the customers because I was traveling a lot. In fact, that was probably one of the main reasons I took the job. We were pretty modest as a family growing up, so I didn't travel a lot, and I really wanted to get out. Getting all this feedback, I designed the concept of a new machine in 3D. engineers do a lot of work with CAD programs. And I said, I'm going to go one step further. I'm going to animate it and have the parts moving and things like that. And I did a little camera fly through. If I were to look at it today, I would have probably laughed my head off because it's probably embarrassing to even look at. But it got the message across. I had spoken to some of the engineers beforehand. We had a meeting. I said, hey, I got this idea. They were mild with the whole idea. Once I had designed it in 3D and I sent it off, it was, hey, how'd you do this? This is cool. What a great idea. You know, I just want to say that's what we talked about at the meeting. It was the first time I really understood that some people are very visual and that if you can design something in 3D or present something in 3D, they can really understand it as opposed to talking about things or scribbling something on paper. When you want to minimize the amount of imagination that somebody puts around your idea, you have to show them something. From there, I started looking at other areas like robotics, assembly lines, where 3D might be useful. I came upon forensics. I saw an article about how people were using it for crime and for crash stuff, and it stuck with me like a virus. I couldn't let it go. Eventually, I said, you know what? I need to make a move in this area, and I'll do something on my own. So I moved back to Canada from Western New York. I worked for about 5 years at another company, learning 3D skills, how to animate, and that sort of thing. And in 2005, I finally made the jump. I said, I'm going to officially start a company. That was AI2 3D. And people ask me, what does it mean? It doesn't mean AI, artificial intelligence, although it seems to be helpful nowadays that everybody says AI. But it stood for animation, imaging, illustration, and 3D. The majority of what I do today is the 3D part. I don't do a lot of animations, imaging and illustration, not as much. I started off doing work for the accident reconstruction people in the area here. It's the low-hanging fruit. There's more money floating around with insurance money and lawsuits. That's how I got started, through the people that I met. I don't know what happened, but I got involved on the shooting case. And after that, they just seemed to keep coming. The majority of my work today is on shootings. There are some civil cases that I work on, but most of it is homicide related. So I usually tell people the two things that I focus on are B, and it's not bed and breakfast, it's blood and bullets. So those two things are what I like to do. Yeah, and there's more to obviously my work. You talked about Recon 3D. That's more recent. Maybe we could talk about that later. Training made up a big part. I know that you're a FARO trainer. I was doing a lot of training for agencies, police agencies, but I do other training like in cloud compare, photogrammetry, 3D modeling, and I'm an adjunct professor at the University of Toronto. I got involved with them years ago. I have the only 3D forensic mapping and reconstruction course that I know of, at least the way that I'm teaching it, exposing students to all these different 3D technologies, you know, at the university there. So it's a fourth year class. I haven't taught it in the past couple of years just because I've been so busy, but I started teaching it in 2013. And so I may switch that back on, but in return, though, I have always taken students on for research. Being part of the university, this year I've got about 9 students doing different projects with ballistics and bloodstain work and even some other areas too. Yeah, that's it in a nutshell.
Yeah, it's fascinating. We kind of parallel a lot. My undergraduate stuff was in construction management of all things, and one in law enforcement. But all throughout my career, it was always the technical engineering aspect of it that it gravitated to. So crash reconstruction, crime scene reconstruction, forensics, anything that had some science behind it. So I can feel your pain in that growth and understanding. It's a great story. Yeah, you've done a lot. It's the last few years, and your growth has been incredible. And that does bring us to what you're currently doing. You've got a lot of background. And anyway, watching that, Eugene is at AI2-3D.com. That's his website. I challenge you to look at that and see what he's into. He's got a lot of good information there. And so we'll move into the next question, which was share us the story behind your Recon 3D is what we're focusing on today. And what kind of motivated you to start that portion of your business?
Yeah, so Recon 3D, let me go back before I even started that. I work privately, right? I don't work for a police agency. So it's a lot of the tools out there are expensive. And so if you buy a $70,000 laser scanner, you've got to work really hard to pay that back. A lot of people don't realize that's a very big investment. And I remember first time negotiating this with my significant other saying, hey, we're going to be putting some money into this thing. And she's, for a laser, what? Like, what are we getting here? It's very costly. And you're always looking for low cost tools that are going to be bringing you value. So I had looked at a lot of the early sensors that came out, like the Microsoft Kinect sensor. There were sensors from Intel. I've got one back here. So these ones here, they're like the little Intel sensors, and they have a little infrared projector and infrared cameras and color camera. So you can use these to scan, to collect data, which is great. But everything fell short. It just never really hit the mark for me. You'd run into problems outdoors in sunny conditions. There were certain things that would give you a lot of problems. But I didn't give up. I kept looking, and over the years, there were like some advancements made there, other apps and things like that that have come out. And shout out to, for example, Dot Product. Like they've been doing some really amazing work with the Kinect sensors, the PrimeSense sensors when they first came out. Just a good team of people and great little product. What they're doing with low-cost sensors is really cool. I had met David Boardman in about 2010 or 11 around that time. At the time, they were called URC Ventures or URC Robotics. They did a lot of photogrammetry processing, thousands of images. There was some relationship with the Department of Defense as well. I don't know the exact history, but it's something like that. And anyway, they had started another company called EveryPoint. They have a related business that does stockpile measuring and things like that. I looked at this EveryPoint engine and he said to me, hey, we got this product. I want you to take a look at it. So I was like, okay, yeah, let me have a look. I had tried it. And my first reaction was, hey, that looks pretty good. The first thing that I do when I get something is I try to break it. Like, where's it going to fail? So there are two places where most 3D technologies will fail. One of them, if you're using something related to photogrammetry, will be on a very flat surface. So if you've got a big white wall and it's featureless, there's not a lot of points or high contrast points on that wall, these things fail. Okay, so if you run a photogrammetry project, you either get a lot of noise or you get no data at all. I had a flat white wall and I said, that's pretty impressive. The next one is shiny black cars. If you get a really shiny, nicely polished vehicle, you'll know from your experience that if you scan with even a terrestrial laser scanner, those expensive equipment, you come back and you're like, oh, that doesn't look so great. So photogrammetry really has a hard time with things which are reflective and shiny as well. And scanners are no exception there. I was surprised at the quality of the data that I got. I was like, wow, I'm getting something decent out of this. And that's how it started. We had discussed creating an app, and I think it was him who really actually pushed me towards it over the edge for getting it started. So this would have been 2022, yeah. And just went forward. We got the app developed, the very first one, and I just put it out there. The date it was launched was May 5th, 2022. Since then, there's been a lot of developments. It's been a learning process. I've got my regular work, cases, teaching, and then I started this thing, which is like a second career. It takes a lot of time on debugging, development, and working with teams of people. There's many moving parts in this business that you have to stay on top of. So it takes a lot of time, but the people who jumped on first were the accident reconstruction, people doing collision investigation. They gravitated toward it, they tried it, and they bought it like right at the beginning. So I think it's partly because of the type of work that they do. A lot of these people, especially on the private side, they're doing vehicle inspections. So they go out, it's after the fact, to a yard, and you have to scan a vehicle, tractor trailer, or something like that. They typically would have maybe used a grammetry or a terrestrial laser scanner. So now they were pulling out this device and they were scanning it. It's really quick, and the quality of the data seems to be enough for the type of work that they're doing, whether it's for crush or analysis, whether it's for just looking at the overall damage. That's where it got started. That was the journey through this thing. It was scary. I can tell you that it still is scary even today. We've obviously grown in the number of users since we first released. It's a precarious business for sure. But I think when I see people who are using it for work, it gives you a certain satisfaction. That's the biggest compliment you can give a developer. Little by little, we're growing with more people. We've committed to doing a lot with this app. We are focused on the forensics area. I would always recommend to people, go try these other apps, and a Polycam, Scaniverse, 3D scanner app. Go look at them because they're there. They may be low-hanging fruit, right? In some cases. But we're focused on forensics, whereas they are focused on everybody, whether it's kids making models for gaming or like whatever. My main focus is people that are doing collision reconstruction, crime scene reconstruction, fire, all those different areas where the data may be used for court. And so that's been my main focus. And what that means is it's not just about the app. There's a lot of things surrounding the app that I've had to put a lot of emphasis on. One of them, for example, is how do we get the best accuracy possible out of the app? One way is by using targets. We're one of the few apps that has targets that we use to help do a fine adjustment on the point cloud data. And that helps to get you a little more accuracy and better control. It's always a good practice, whether it's a laser scanner. I'm sure you probably teach this in your classes, right? You say, hey, always do a check. You may be scanning with this. Yeah. Go back and just lay out a tape measure and do a double check and make sure, use a laser distometer or something like that. So I promote that a lot. We have a training course. At first I thought about it, geez, I got to have a course for my app. And I'm like, yeah, hell yeah. This is forensics. If somebody's going to be getting on the stand and talking about the data they're using for an app, they are going to be asked, have you been trained on this? How do you know this works? How can we trust this? The fact that we have a short course and every person has to do their own validation of the app, meaning they have to do their own project and check for themselves the kind of accuracies they can get under certain conditions. That's been a really valuable exercise for a couple of reasons. One is that people prove to themselves what it's capable of and what it's not capable of. And so I always tell people, if you really know the tool that you're working with, you know where it doesn't work, right? You know where it gives you problems, you know where not to use it and not to cross that line, so to speak. That's been really helpful. And then, of course, if they finish the assignment, they get a certificate. And that certificate is valuable to many people when they're going to court. Some of the data that we've captured on the training courses, we've used in research publications, like validation publications. We have 5 published papers on the website, and we're going to continue to do this. We have a couple of papers right now, one on bullet trajectories, another one on clandestine grave documentation, looking at the accuracies and what we can get out of the app. All that is really important for forensics. I'm not so interested in being able to say, hey, Recon 3D is accurate to 2 millimeters or 100 thousandths of an inch. In fact, if somebody says, I did this project and it got so accurate, I tell them that's great, but please don't go out there advertising that because you're going to kill me. Like you're going to cause more problems than good. And so I'm quite fine with somebody saying it's accurate to a half an inch, it's accurate to an inch or whatever. In forensics, it's not about the actual accuracy, it's about the uncertainty and the errors. You need to know what that is. And so I put it out on the table and say, this is what we found. We did this exercise, this is what we found. We did a bloodstain project or a series of tests, this is what we found. I think that's something that is unique to us. I don't have to go out there and say, I've got the most accurate iPhone app out there. But what I can attest to is we have the most scientifically studied app out there. And that to me is what is even more important.
Yeah, it's a great point. In our business, as you're probably seeing, that focus for you is probably because of your courtroom approach, right? So you want to be able to back it up, which is fantastic. I love to see that because that's what it takes. You're hitting on some research concepts that are really important. Transparency in your error rate is big, and we know it's always there. It just shocks me to see that the history of experts in courtrooms have said, without a doubt, they're 100% accurate. And I'm like, what are you thinking? Anyway, I'm not true scientists, right? They're petty, they have a little ego overcoming that. You mentioned Recon 3D. What is a snapshot for somebody that may not maybe new to that technology, like you're saying, a Reconstructionist or something, of how you're utilizing the iPhone to capture that data? Just a short understanding of that. Could you give the audience that?
Yeah, sure. So Recon 3D works by fusing 2 different technologies together. One is photogrammetry, and the other one is what the LiDAR sensor on the iPhone gives you. So but there's a little black dot on the phone. That little black circle is the LiDAR sensor that first was released in 2020, and I think it was the iPhone 12 Pro and the iPad Pro at that time. What that does is it sends out a grid of dots. There's 2 sensors. The iPhone 15 has a slightly different sensor pattern that it sends out. The first sensor was a 12 by 12 matrix of dots, and it shifts, it moves around. So when it moves really fast, it looks like an interlaced pattern, like a larger overall pattern. And what the device is doing is it's measuring the distance to each of those dots. Inside the Apple framework, you take those dots and convert them to an image called a depth map. For example, if I had an image of a hotel room or a roadway, points farther away would be blue and points really close would be red. Each pixel in the image would have a distance associated with it. So it's a flat image, but it has a distance. That depth map is useful in many types of augmented reality projects and virtual reality, all kinds of different things where you're doing reconstruction work. So that's the LiDAR sensor. Then there's photogrammetry. Photogrammetry is a way of collecting a series of overlapping images and be able to create a 3D model from it. So whether it's a mesh model or a point cloud, a lot of people are familiar with drones on roadways. The benefit of fusing these two technologies is photogrammetry tends to break down when you don't have a lot of features. If you have a white wall and you're starting to move, it just sees white wall. It doesn't know what that is. It doesn't know what it means. But there are other sensors on the device. There's accelerometers, there's GPS, there's all kinds of things. But when you take all these things and put them together, the two main ones being you're recording video and LiDAR. Imagine if you could have a frame or a picture of the video, and inside of that, you could associate that with the depth map. So if you pick on a pixel in the image, it knows how far it is. That white wall, where it had no clue where it was, now it knows where it is. It knows how far it is. You gain benefits from using each of those technologies and fusing them together, and you get out of troubled areas. So it helps you by fusing those two technologies together. Some people will say Recon 3D uses the LiDAR sensor, or they call it LiDAR. It is. But you really have to think of it the other way around. It's more like photogrammetry assisted by LiDAR. That's the best way I can describe it. So it is LiDAR, it is using the LiDAR sensor, but photogrammetry is the big piece of it that's being assisted by the LiDAR sensor, and that's how it works.
Yeah, I think that's a good understanding. People are thinking LiDAR and lasers, the big things, and it helps that accuracy. But like we're seeing, I think outside the box, when we combine, like you're doing, photogrammetry, LiDAR, sensors, we're getting something that's much improved. And as we're seeing with other technology, I found myself in that situation recently with some research where I was overthinking. Luckily, I have a partner that was asking me questions. The end result was keeping it simple was the best way to do that. Thanks for that recap. One thing I want you to touch on, if you wouldn't mind, is your challenges in courtroom, in 3D reconstruction, and the different things that you presented. What are some keys you've had to overcome with courts and juries that would help us understand what's happening now and what's maybe going to happen down the road?
Yeah, in the courtroom, there's a few things really, if you want to look at it in a broad spectrum. One of them is some of these technologies are rather complicated. You want the jury to feel comfortable with the technology that you're using, whatever that might be. For example, a laser scanner. How does this thing work? They may ask the question. And on 2 occasions, I've had to bring the laser scanner in the courtroom and demonstrate how it works. Scanning the courtroom with the jury there and then showing them the results immediately. And that was a very effective way for them to understand, this is the process that I use, this is how I walk through it, and this is the result that you get. And when they see it firsthand, that works great. I know of some people who they'll go in early, they'll scan the courtroom with nobody there, and then during their testimony, they'll actually bring it up and say, hey, look, I was here yesterday, I did a scan, and this is what it looks like. So communicating how the technology works in a simple way is always a good idea. Other challenges are always having some kind of way of communicating what the errors are. And so this is also fairly complicated, depending on the technology that you're using. If you're using photogrammetry, that can be really complicated because photogrammetry doesn't have a calibrated certificate. You're using a camera, it could be from a drone, it could be an expensive digital SLR camera or mirrorless camera, it could be your phone, right? So the question is, what kind of accuracy are you getting out of your photogrammetry project? And that is a little bit harder to quantify and is complicated to explain. So doing simple things like just having control measurements, just having a few measurements that you can say, hey, look, I measured this with a tape measure. I've got 30 feet here, and I checked it in the photogrammetry model, and I'm getting 30.01 feet. That's a simple way to communicate your accuracies, but you always have to have it there. So that's something you must have in your back pocket at all times. You asked about the courtrooms, and some of the challenges is presentation of 3D data, being able to give a product that is useful. And so oftentimes, if I'm doing a shooting reconstruction, if I am doing some kind of a project or a case that involves a 3D model, I'll bring it up on my screen during trial. I can move it around and I can put it where I want it as part of my testimony. Some people will do, for example, animations. Those are good. That's something that a jury can usually understand quite well. And there are other ways to share data. One of the outputs now of the laser scanner is a virtual tour. It uses the panoramic images from the laser scanner as a basis, but it's what you would get in Google Street View. You could do the same thing, more or less, for a crime scene inside of an apartment or something like that. And so that's cool, like being able to share that kind of data. And there's also taking that data and producing other things from it. For example, in a case I had, I created a virtual model of the scene using a gaming engine. So this is going back now. This is probably like 2010 or something. It was a lot more effort back then. I think it's easier to do today. But I put everything inside of this 3D viewer. It had a lot of shortcut keys we could program in, and that went into trial. And so people can fire it up, they could look at it, and you were able to move around like a video game and isolate specific moments. It was an officer-involved shooting in Atlanta, if I recall correctly. Yep, it was pretty novel at the time. I think back and I'm like, geez, that was pretty cool. So that was another way you can deliver 3D data and even 3D printing. There's nothing stopping people from taking scan data, meshing it, creating a model, and then having that model printed. It's great because you can take big things and make them small. You can take small things and make them big. I've got a couple of examples here. One is just a very simple thing. This is just a footwear impression. This came from a photogrammetry model. So I took photos of this and I shrunk it down. Obviously, nobody has a foot that small, but it's easier to carry around in your bag when you're doing presentations. If you are somebody that's working with tire tracks or footwear impressions, you can have a model right there with you. I need to print out a new one because I gave it away. So we're doing some work with postmortem fingerprints. Sometimes if the body is far gone or hasn't been found for a while, it's very difficult to roll a print off the fingers. We have a method where we've taken photographs. You can actually get it to the point where you can reconstruct the ridge details on your fingers. When you print it out larger, you can see it, you can feel it. If you're a latent print examiner and you want to use that at trial, that's pretty cool. This one here is a vertebrae. From a homicide trial, actually, a woman was killed. We scanned her bone because we were doing some reconstruction work with the weapon and how it aligned with the bone. You can hold a copy of somebody's bone in your hands and use that to communicate something. Of course, you would never bring a real skull into the courtroom and freak people out by handing it to somebody. Something like a plastic bone or even a weapon you could reproduce in 3D. You have to look at the challenges in the courtroom from start to finish and communicating what you've done, how you've done it, to what degree of accuracy have you done it, and what can you leave the jury in terms of what they're going to take away with them when they go deliberate and make a decision.
Worked with a lawyer a while back that was still doing models, creating death cases, models of the scene. The jury could see how it worked out to scale and everything. And it's really powerful. He said the other side of that, why he did that and kept doing it, was once you get that model out there, they continually look at it. Your screenshots, what you're showing on the picture, shows for a few seconds and then you move on. And I was like, really? He goes, yeah, they could sit there and watch it the whole time. So you could do the same thing, especially with car crashes, with heavy damaged vehicles, like you're saying. If that car is scanned and sitting out there for them to see the whole front end crushed, that's a pretty strong thing in their head they have to deal with.
Yeah, there's something to be said for holding something in your hand, like a 3D print. Let's say, for example, if you're a latent print examiner and you give somebody a copy of somebody's finger, hey, this is the suspect's thumb, and here's a print that we pulled from the scene. I'd like to show you the differences. And all of a sudden they're holding this big 3D finger kind of thing. So you can color code the ridge details and things like that. I think that would be a very memorable thing, something that they would not forget very easily. From an attorney standpoint, they're trying to keep people engaged. And let's face it, like some of these trials go on, you look over it. I've been in trials where the judge says, we need to take a break because these jury members are falling asleep. Anything you can do to make it more interesting will help for sure.
It's an interesting point. I can see where something like that 3D figure color-coded would help a jury understand what that examiner is matching up, because that's pretty detailed work and a lot of terminology involved and explanation. But when they see that, they don't have to memorize all it. They can just go, okay, that makes sense. On the programs, we also have an interest in 3D scanning, 3D reconstruction, and how they intersect with virtual reality. With those technologies in mind, can you give us an idea what you think they're going in the forensic investigations side of what we do?
There's a lot to say here. In virtual reality, there are many applications. If we just talk about virtual reality in general, I think the main area that VR has taken up has been in training. Everyone knows there's like simulation training for anything, for fire, for crime scene, and so many other areas too. That's a no-brainer. That it's a great tool to give another way of learning. So I like that. But in terms of actual casework, there are some things where it can be used, but there are some limitations too. I did some bloodstain analysis inside of it. This was an exercise that I did at the Ontario Police College. We did some exercises and stuff, but I scanned they have like these apartments where they do training. So we did that and I overlaid the results of my bloodstain impacts inside of this point cloud. And I sent all that data to a researcher in Stuttgart. His name's Dr. Uwe Vossner, and he has what's called a cave. So it's not glasses VR, it's a room that has projectors on all sides. So when you walk in, you're immersed in this 3D environment. I thought that was interesting because from an investigative standpoint, he's inside of this scene, but he's also interacting with the results of my analysis. So I thought that was an interesting way of using VR, not just for looking around, but actually for seeing another way of delivering results and somebody interacting with it. I think VR will have more to say in the future, or I'd like to see it used more. I had a really interesting case recently where it would have been perfect. Unfortunately, it didn't go to trial, but it was an officer-involved shooting. What somebody could see is really useful in VR. That's its strength, the fact that you're there and you're getting a perspective on if I'm standing here versus someplace else, what am I seeing? What am I not seeing? That's another strength of VR that I think a lot of people don't talk about, but one in this particular case that would have been really beneficial. I think it is a big jump to say, we're going to put the whole jury in VR. We're going to take 20 people and they're going to be walking around the courtroom or something like that. There's obviously some technical limitations and some logistical issues that have to be overcome first. A first good step would be, for example, when we talk about full VR, we're talking about 6 degrees of freedom. So you're moving around, you're walking around, you can move in that space. But if we take a step back and go to 3 degrees of freedom, in that case, you could be seated in your chair. You can rotate around, you can look around, but you can't move forward or backward or up or down, but you're stuck inside of the bubble, let's say, but you can look around. And what I like about that is you could have a person, whether it's an attorney or an investigator, giving you a virtual tour of a crime scene. That's easier to do because you can set everybody up. You can set 20 headsets up and walk everyone through the crime scene. Somebody can be like the tour guide. Okay, let's go to the kitchen. Everybody look to your right. If you look to your right, you can see on the ground, there's a knife, there's some blood. Okay, we're going to move now to the hallway. And then, they basically flashes up or shuts down one image and it brings up another image of the hallway. And so that is much easier logistically to handle. I'm hoping we're going to be seeing more of that inside of the courtroom as time goes on, because that would be a great intermediary step before we get on to full VR and getting all these people suited up. But there are some things you could do in a cave type environment. And I know that here in Canada, maybe a few hours away, there's a very big cave system. So basically it's one big projector, but you can have multiple people inside. Instead of everyone having their own headset and being in their own world, they could all be standing in the same place through the projectors and what's around them. You still need glasses, but it's not the same type of glasses. You would see everything in 3D. That is obviously not going to be something you bring to the courtroom, although you could, but it would be easier to just take people out of it and bring them to a location where they could experience the crime scene and everything inside of virtual reality. I think that's probably why it really hasn't taken off so fast. There's some limitations on how we get there. Certainly the part of creating the content for VR is excellent. We have photogrammetry and lasers, like all these things that we have now, we've got that part down. But then once you bring it in, what to do with it, how you set it up, how you make it interactive, and so forth is a lot more difficult. I think we still have a ways to go with VR, but hopefully, like I said, that intermediary 3 degrees of freedom step would be much more achievable and easier to do. I'm hoping that more people focus on that in the near term.
That's a great point. And I love those points, Chris. Those are things that I've always been interested in the courtroom and helping the jurors understand things. Could they happen? Let them truly decide. And I think we'll get there. I know there's some civil cases that have used it in various aspects, but I would like to see, like you're talking about, them be able to look into a crime scene. It doesn't have to be the gory section of it, but you can at least represent it and show them spatial-wise how things. And a lot of that is long, extended explanations of what could happen and what could somebody see, and you could just put them in there, let them see it. Yeah, I like where you're going with that. A lot of good points there. So as we move forward, I know we covered a lot in our final segment. Is there anything else you'd like to share with the audience about Recon 3D, the future of it, and your forensic technology aspect?
Yeah, sure. Two things. I don't know if you set me up on purpose talking about courtroom visuals or whatever, but it'll lead right into what I'm going to talk about. But the first thing is right now we're doing a complete rewrite of the app. So we've started from scratch and rewrote the whole thing. That'll be released sometime in the future to help open up the architecture. And there was some learning along the way and things like that. So there should be some performance improvements, integration with companies like Axon. So people who have an Axon account or police agencies that are using Axon, they'll be able to upload to their like evidence.com accounts and such. So I'll look for that in the near future. The second thing is we were just talking about juries and courtroom visuals. So I will be announcing a new product in just a few weeks, and that is called Vision 3D. And I don't even have it on the website yet. The idea of Vision 3D is that it gives people a way to share the data they collect with the app. One thing I found in the training courses and with people coming on board to Recon 3D, a very large percentage of people are brand new to 3D. You're a person that has experience with photogrammetry and laser scanning and these other technologies. Imagine somebody walking in from zero and they have this app, they scan and they collect some point cloud data. There's a big problem because what they end up doing is they spin it around on their screen. They go, hey, check this out. And then that's it. They're stuck. It's no coincidence that usually about a month after I have the Recon 3D course, I have a cloud compare course so that people can learn how to manipulate the data and how to take measurements and how to do different types of analysis. I want people to share the data in the format that it exists. I'll be coming out with something called Vision 3D, a way of importing the data. It's an editor. You can bring in multiple point clouds. You can bring in FARO data or meshes and combine them if you like. Once you put them into this editor, you'll be able to create a virtual model that you can share with people. If you have photographs from a crime scene, you can tag those in there with the bubble tags. You can add video, add 360 imagery, documents, measurements, text. It's giving you a whole bunch of different features that you can append to the point cloud so it's more meaningful. Once you're done in the editor, you can export it as a zip file. I can share that with you. I could share it with anyone else. And if it's PC based only right now, you could put it on another PC. And I'm thinking about courtroom. I'm thinking about sharing that data with the jury so they can take it back for deliberation. And they just run it and they get a very simple interface and they can rotate around, rotate the model around, zoom in, zoom out, pan over, but they get access to all those links. If it's a vehicle that's crushed and there's a very important scrape on the side, you can zoom in on that point and add an image there. Or you can even add a viewpoint. You can say, look, you need to focus in on here. When they double click, a little eyeball flies into that particular position. They're like, oh yeah, that's what he was talking about during his testimony. It's this little gouge mark here. You can append your reports and it's a nice way of sharing 3D data. I wanted to make it completely offline because there's a lot of just agencies that just don't want to share anything online. So it's a pretty simple tool. There's a lot of room for it to grow, but it's in beta testing right now. We're just finalizing some things. I just got another beta yesterday that I was testing. So probably in 3 weeks, there's going to be an announcement on it. I'm really looking forward to it. I'm excited about it because I think it really will open up the door for people to just sharing the data in 3D in a very simple way. Think about an attorney or think about a client that just, they're not technical. They're not going to be opening up Cloud Compare or other software packages. And so it's very similar in principle. Leica has TrueView, right? These virtual tours. The main difference being in those cases, the panoramic image forms the basis of the virtual tour. And with Vision 3D, the basis of the whole, I wouldn't call it a tour, but it's a virtual model. And so it's the 3D data itself that forms the basis of the whole experience.
Yeah, I think it's going to take off for you. That's going to be a really strong tool to take that to the point. I've noticed that since we've talked about your application, there was a lack of how do we get it into the courtroom? Like you said, there was some virtual options, but it wasn't, I think it was all encompassing. It was limited. I appreciate you reaching out and getting your focus on the end result and how do we present this to other people, not just lawyers, but then the court and the juries. I think you're on the road to a good place with that for your users for sure. It'll be interesting to see outside of the Recon 3D arena, who else reaches out to you.
Yeah.
A simplified tool like that is a needed asset. Actually, Eugene, thanks for everything. I appreciate your time. If you'll hang tight, I will close this out and get back with you. We'll finish up.
Thanks so much, Ryan. I appreciate it and look forward to seeing you sometime soon. Hopefully we'll catch up again in person sometime.
Oh, absolutely. I hear you.
All right.
I'll be right back with you. That wraps up another insightful episode of the Virtual Reality Reconstructionist. Thanks to Eugene Licio for joining us today and sharing his invaluable insights on 3D forensic documentation. To the listeners, thank you for tuning in. Remember to follow us on your favorite podcast platform for more episodes of exploring the fascinating world of virtual reality and forensic investigation. Until next time, this is Roger Ryan Ryder signing off for Triple R Investigations. Stay safe and stay curious.